Okay, continuing in 7.5, we're up to example 7. And they have this whole little shadows in a ballpark scenario. And if you look at the picture in the book, you'll see what's happening here is this is 150 feet to the top of the stadium. The sun is out here somewhere, casting the shadow. This is my shadow down here. This is my angle of elevation from the horizontal, and this is the line L. And the question says, express theta as a function of the shadow length L. Okay, so theta using L, but not using, not L, S, that the shadow length S. So using S and not using L, that means I'm using the opposite and the adjacent, which would be the tangent of theta is equal to 150 over S, which means that S is equal to, no, they want theta. Theta is equal to the arc tan of 150 over S. So that's part A. Part B wants us to compute d theta over ds when S is 200 feet. Remember, you can't put that in until after you take the derivative. And explain what this rate of change measures. Well, it's changing the change of the angle with respect to the length of the shadow. So, how do I take the derivative of this? Well, let's see. The derivative is going to be d theta over ds is equal to arctan. So that's going to be the derivative, let's see, u is 150 s to the negative 1. So du is negative 150 s to the negative 2. So that's my du, negative 150 s to the negative 2, over, arctan is the 1 plus the u squared. If I clean this up, I have my negative sign, I have 150. If I bring the s squared down, and this is 1 plus, the book says 22,500, I'm going to believe them, over s squared. If I distribute the s, I get negative 150 over s squared plus 22,500. So there's my derivative. And now I need to plug in the 200 feet. So that gives me negative 150 over 200 squared plus the 22,500. And you get negative 0.0024. Now, what are the measurements on this? This would be not degrees, because calculus is done in radians. So radians per the shadow is measured in feet. So when the length of the shadow is 200 feet, the angle of elevation is changing at a rate of negative 0.0024 radians per foot. And the book also translated it into degrees. It turns out that it is negative 0.138 degrees, moving very slowly per foot. Okay, example 8. Now we're going backwards, and we have these integrals. And the integrals look like the reverse of what we were doing before. And so, I guess I can write them down. Let's see. One of them is dx over the square root of a squared minus x squared. And this would be the arc sign, because it's got that 1 minus x squared, only a doesn't have to be a 1. So it turns into the arc sine of x over a plus some constant c. If you integrate dx over a squared plus x squared, now that's got to be the arctan because you don't have the square root and you have a plus sign. And again, it's x over a plus the c. Oh, except that there's a 1 over a in front of it, because it has to take care of that extra a that's in there. The third one, if you have dx over x the square root of x squared minus a squared. Okay, now that looks like the arcsecant. And again, you have a 1 over a. You have an arcsecant of x over a in absolute value Mars plus some constant c. So those are the three rules that we use. We don't need the three others because you can just take care of them with that extra minus sign. So part A wants us to integrate 4 over the square root of 9 minus x squared dx. So I like to look at this as the a is 3 and the u is x and du is 1 dx. So the 4 is unnecessary. So the 4 is just tagging along for the ride. So I'm going to pull it out. And then this turns into the arc sign of u over a, so that would be x over 3 plus c. Part B wants us to do dx over 16x squared plus 1. Okay, so for this one, the a is 1, the u would be 4x, and the du would be 4 dx. And I don't have the 4. So I need to put a 4 in the numerator, which means I need to put a 1/4. Oh, they don't want to do it that way. Let me look at it. All right, the book did a little bit differently than I did it. I'm just going to let it go like this because it comes out the same. So I'm missing a 4, so I need a 4 on the inside, a 1/4 on the outside. So I'm actually integrating, this would be, I'm going to write it as du over, and this is your u squared plus your a squared. And so that just turns into 1/4 is hanging out. The formula has a 1 over a, so that's going to be 1 over 1. Then you're going to have arctan of u over a, so that's going to be 4x over 1, plus your c. So the 1 over 1 doesn't need to be there, so we get 1/4 the arctan of 4x plus c. It's done a little bit differently in the textbook. If you look at it, they factored out a 16 to get rid of the 16 in front of the x squared, which makes your a to be 1/4 squared, because you have a 1/16 then. So that will work as well. I don't like the fractions, so I didn't use them. This next one is doesn't have a plus c because we've got values here. It's a definite integral. 5 over the square root of 3 and 5. And then we're integrating dx over x square root of 4x squared minus 25. Okay, and they didn't mess with it this time, so we're going to do it the way I've been doing it. In this case, it looks like an arcsecant. My u is going to be a 2x because it's the square root of the 4x squared. Oh, my a is 5. My du is going to be 2 dx. I'm going to have to stick a 2 in because I don't have one, and a 1/2 out. And then this is going to be the 2 dx is your du. The 2, oh, wait a minute. No, that's right. I also have to have a 1/2. I have to solve this guy right here. X would be equal to 1/2 u. So my x in the denominator is going to be a 1/2 u. And then I have the square root of, this is going to be u squared minus a squared. But notice I've got to change my variables out because now I'm not using x's. So the top of my integral was at x equals 5. When x equals 5, u is going to be 2 times 5, or 10. And the other x was 5 over square root of 3, so u is going to be 10 over the square root of 3. Now, I don't need that half that's in the denominator. It's not part of my problem. It's a constant. It can come out. and it's on the bottom. So the half on the top that's on the outside and the half that's in the bottom on the inside actually cancel. So this is going to turn into, the halves are gone. I'm going to get 1 over a, so 1 over 5, arcsecant, and then it's going to be x over a, or u over a, so that's going to be u over 5, evaluated, and the 10 is on top, and the 10 over the square root of 3 is on the bottom. So now I have 1/5 arcsecant of 2 minus the arcsecant of 2 over the square root of 3. So that's 1/5. When is the arcsecant? Arcsecant is 2. When is the secant 2? When is the cosine 1/2? That's at pi over 3. And then the arcsecant of 2 over the square root of 3. When is the cosine square root of 3 over 2? That's at pi over 6. Which means I have 1/5 2 pi over 6 minus pi over 6. So I end up with pi over 30 for my answer.